Morning, everybody. Once again, Dr. Salim is here with you guys. Let's talk about some more questions, exam review questions. Let me share the screen with you guys for SPI examination, just in case if you need to sit for that board examinations. Okay, let's see. The question is, the narrowest point of a sound beam is called what? The beginning of the sound beam, the focal point, the end of the sound beam, all of the above, all of them, none of them. What do you think? Which one is the correct answer? Yeah, what do you think? Exactly, you're right. The focal point is the area where the sound beam is more narrowest. That's the area where the conversion happen, and after that diversion will happen. So the sound just center to that point. That's the narrowest point of the diameter of the beam diameter. Good one. All right, let's do the next question. Choose the correct option for the intensity calculation formula. What do you think? Which one we can use, or which of the following options will give you the formula for the intensity of the sound calculation? What do you think? Intensity is equal to power over area. Intensity is equal to amplitude at the power of 2 or square. Or intensity SPTA, spatial peak temporal average. We can say is equal to intensity of spatial peak and pulse average times duty factor, or all of the above. What do you think? Which one is the correct answer? Well, you are right. That is correct. All of the above, because all these intensities, these are the formulas. Now it depends what the question will be asked. So you're looking for the material in the question, what they give you. Are they giving you power and area? Are they giving you only amplitude? Are they giving you SPPA intensity and also the duty factor? Then regarding them, you're going to use the correct formula for them. So all of them is the correct answer. Good job. All right, let's do the next question. Okay, good one. Okay, this question is asking that what are the units for sound amplitude? So what do you think? Pascal, megapascal, decibels, all of the above, none of them. What do you think? Which one is the correct answer? Very simple and easy question. Exactly, you're right. All of the above. So we call it pascals, megapascals, and decibels. But most commonly we use megapascal. That is the one we are using the most. Good job. Very good. Beautiful. Okay, let's do the next question. Now, choose the correct units for the sound intensity. Because everything has a unit, correct? So now, what is the unit for the sound intensity? What do you think? We have option A, B, C, and D. Exactly, I'm agree with you. Milliwatt in a centimeter square. That is absolutely correct answer. Let's do the next one. Okay, this question is asking that we measure the amplitude of the sound wave to have been 10 decibel. What will happen to the intensity if we double the amplitude? What do you think? So this question is actually, you have to know the formula first of all. Just we mentioned it earlier, right? There were 3 formulas for the sound intensity to figure out. Now, this question is a little bit tricky. Tricky means if this question was asked only that what is the sound intensity if the amplitude is only 10 decibel, then that was easy question. But it is asking in a question, there is another question. It says calculated, but if we double the amplitude. So right now the amplitude is 10. So if we double it, of course, it will be 20. Now, if your amplitude is 20 decibel, what do you think? How much will be the intensity, SPTA? Correct, 400 decibels. C is the correct answer because it's amplitude at the power of 2. So now if we have, instead of 10, we have 20 at the power of 2. So it means 20 times 20, and that will be a 400. That is the correct answer. Good job. Let's do the next one. Now, this question is asking, the SPPA intensity is 200 milliwatt in a centimeter square, and the duty factor is 2%. What would be the SPTA intensity, spatial peak temporal average? So you have already one of the intensity, spatial peak pulse average, and that is a 200 milliwatt in a centimeter square, and you have a 2% of duty factor. What do you think? Which one is the correct answer? A, B, C, D, E. Yeah. Yes, you're right. Exactly. Because the formula, if you remember, we had SPPA intensity times duty factor. Now, duty factor here is, of course, it's by the percentage. So 2% you cannot multiply with this number. The other shape or form of writing 2% is 2 divided by 100. That's another shape of writing or form of writing of 2%. So in that case, if we write a 2 divided by 100 and times 200 on that time, because this is our SPPA intensity. So these two zeros will cancel the two zeros of the below the denominator, which was the 100. So now 2 times 2 is 4. So the first answer is the correct answer. 4 milliwatt in a centimeter square. Absolutely correct answer. Let's do this question. From the following intensities identities, which one is causing bio effect? Which one is causing more heat to produce in the soft tissue? What do you think? SPTA, SPPA, SPTA, SATP, SATA. What do you think? Which one is the one? Exactly. SPTA, special peak temporal average. C is the correct answer. Don't forget about that because that will be one of your questions in the ARDMS. Now, let's do this question. From the following intensities identities, which one yields the highest? Which one is the highest intensity, which produce the highest intensity? So we have SPTP, we have SPPA, and we have SPTA, SATP, SATA. What do you think? Exactly, I'm agree with you. A is the correct. Why? Because we have special peak, temporal peak. Everything is in the peak. That is the correct answer. Good job. That's the highest. Maybe the next question is almost the same, but with a little different. All right. The question is asking from the following intensities, identities, which one yields the lowest? Like really safe or very with no concerns. SATP, SATM, SPTP, SPPA, or SPTA? What do you think? Which one is the correct answer? Yes, correct. Yes. Special average, temporal average. Everything is in the average. Nobody's in the peak. So SATA is the correct answer. That's the lowest intensity. Okay, let's do the next question. The next question is when final intensity is half of the initial intensity, calculate it in decibel. So we all know the intensities are in milliwatt in a centimeter square. That's the unit for them. But to calculate it with a different unit, there are decibels. So decibel is also the unit for the intensities. So that form to calculate it as an a decibel. Now, if the primary, the beginning, the initial, the starting intensity become half somewhere in the operation or in when you're scanning. So somewhere it become half. For example, if you had 400 milliwatts per centimeter square, if that is your intensity of the beginning of the probe. Now, and somehow in a depth, somewhere in the depth, it become 200. From 400, it become 200 milliwatt in a centimeter square. So what do you think, how much intensity we had it? How much is sound, how much sound we did last already? So how that would be calculated? Yes. I'm also agree with you. That is minus 3 decibel. So remember, when the initial frequency, the initial intensity become half, like somewhere in their trap or in their penetration. So remember, that will be equal to minus 3 decibel. That is the correct answer. Now, almost the same question, but with a different numbers. So it is asking like this question, 150 and 151 is almost the same question. When the final intensity is 1/8 of initial intensity, calculate that attenuation. Now, same question, they are the same almost. Now, before it was telling you that if your final intensity become half of the initial, like initial become half, so that was 3 decibel. That was the answer. Now, if your final intensity is 1 over 8, it means if your all intensities from the beginning, we divided them with 8 parts. Now you have only one part. The 7 are gone. So how much attenuation happened? How much sound did we lost in this? So by the decibels. If it's 1 over 8. Exactly. You are absolutely right. That's 9 decibels. That is the correct answer. Absolutely correct. Good job. Okay. Now, there is a formula for this. Okay. So now let's do the next question. When final intensity is 1 over 1000 of initial intensity. So calculate the attenuation. Same like above question. So now after 10, look to the zeros. The easy way to learn them. So look at the zeros. We have 3 zeros there, correct? So that will be 30 decibels, minus 30 decibels. So there's 1 0 always here, and then we calculate how many zeros are there. So from after 10, that 1 0 is after 10 is coming. So that will be like, now we have 3 zeros here, that will be 30. For example, if this was 10,000, in that case, 1 0 is already coming after 10. Because if it's 1 over 10th, that's the minus 10 decibel. But if it's 1 over 100, that is minus 20 decibel. If it's over 1 over 1,000, so that will be minus 30. If it's 1 over 10,000, that will be minus 40. If it's 1 over 100,000, that's minus 50 decibel. And keep going. Okay, so next, here the answer was B. So now let's do the next question. What is the relationship between propagation speed and acoustic impedance? Remember, we had a formula for this. Yes, you're right. It has direct relationship. Why? Because we said acoustic impedance, or a Z, is equal to propagation speed of the sound times density of the tissue. So on that case, both of them, there is nobody below the denominator. So everybody have a direct relationship. That is the correct answer. Let's do the next one, and almost done. Okay. So the question is, what is the average impedance of soft tissue? So we can say, what is the average impedance of sound in a soft tissue? Impedance is the resistance, just by the way. Okay, so how much? Is it 1.63 megarels? Is it 163 megarels? Is it 0.163 megarels? Is it 16.3 megarels, or all of the above? What do you think? Exactly. I am also agree with you. A is the correct answer. It's 1.63 megarels. Absolutely correct answer. That is something constant. Now, next question. Perpendicular incident as known as which of the following? So what are the other alternative names for the perpendicular incidence? A, normal incident. B, right angle incident. C, orthogonal incidence. D, 90-degree incidence. Or E, all of the above? Yes, of course. It is all of the above. All of the above is the correct answer for them. That is absolutely correct. All names are the same, representing same thing. Okay, now let's do next question. With perpendicular incidence, only 2 things are going to happen: transmission and reflection of the sound. It means there is nothing else. Some of the sound will transmit to the next medium, and some of the sound will reflect back to the transducer, and we see the picture. Is this true or false? Yes, it is true, because when you do with a 90-degree scanning, when you scan something, either some of the sound will transmit to the next medium and some of the sound will reflect. It depends. So that is the percentage. Here we look for the percentage of the sound, that how much sound is reflected and how much is transmitted to the next medium. Next question. Okay, this question is also almost the same concept like we had it in 156 question number. So the above question and this, they have the same concept. What happens when there is a higher mismatch between the 2 mediums at the boundary? Let me explain it a little bit. When there are 2 mediums, 2 different mediums, for example, you have adipose tissue and you have muscles. So there are two different mediums. Now the sound will go from adipose tissue, and then there will be muscles below that. So the boundary, the border between both of them, has to be a specific space, or it's not space, sorry, a surface. So that will to differentiate between these two mediums. Of course, there's a boundary between them, border between them. Now the question is, if the mismatch between these two, the adipose tissue and muscle, if they have a huge difference between each other, what happens when the sound go to that boundary, to that border area? What happens? How, like, the sound will reflect, the sound will transmit, or nothing will happen? What happens? So these are the answers. Huge transmission will happen, like big percentage of the sound will transmit. Huge reflection, more like a big percentage of sound will just reflect back from the boundary, will not go to the next medium. Less reflection will happen, or 50% will transmit and 50% will reflect, or none of the above. What do you think, which one will happen? If there's a big, huge mismatch between the two mediums, if their impedance have a big difference between each other. Exactly, that is correct. B is the correct answer. So remember, if we have a big mismatch between two mediums, most of the sound will reflect from the boundary. They will not penetrate to the next medium. When they have good match, like a huge, big percentage match, so the most sound will transmit to the next medium. So remember, match in mismatch. That is important word for us. Okay, let's do 3 more questions. So this question is asking, in case of orthogonal incidence, just we had it earlier, sound enter a medium in which angle? So what do you think? If we have orthogonal incidence, sound is entering to the next medium by which angulation? 0 angle, 60 angle, 180 angle, 90 angle, 45 angle. What do you think? Just we had it earlier. Exactly, one of the name of orthogonal incident, or perpendicular incident, or normal incident, right angle incident, one name was 90-degree angle. So that is the correct answer. 90-degree angle, that will be the correct angle for this incident. Next. Okay, what is the best angle for 2D imaging? Very simple and easy question. It can be asked in ARDMS for sure. SPI. These are all SPI similar questions. They're going to ask these in the physics. These are the questions. They cannot make it more complicated than this. Okay, what do you think? 45 degrees, 60 degree, 45 to 60 degree, sorry, 90 degree, or 180 degree. Which one is the best 2D grayscale imaging angle? Which one is the best? Yes. That is correct, 90 degree. Why? The reason is, with a 90-degree perpendicular, when you scan straight, the reflection come back. There's less chance of scattering to go to the all direction. It will just come back to you. Maximum sound reflected back to you. And that is our information. So we have more information on our picture. Last question, but not least, let's do this. Okay, the question is that when intensity reflection coefficient is 75%, to calculate the intensity transmission coefficient for the sound wave. Now, 75%, 25%, 100%, 0%, or 50%. Which one is the correct answer? The simplest question in the world in the ultrasound physics, but if you understand it, then it's a simple. If you don't understand it, then that's a tough question, of course. And these are the questions from SPI. They will ask you this question. Yes, exactly, you're right. B is the correct answer, 25%. Why? Because remember, in perpendicular incidence, like just earlier we said, you have two things. We have transmission and we have reflection. Now, how much sound is transmitted, the rest of the sound will reflect. How much sound is reflect, the rest of the sound will transmit. So you have to complete 100%. If this question was asked differently, like if say reflection coefficient is 50%, in that case, then E was the correct answer. If this was asked that reflection coefficient is 100%, calculate the transmission. So in that case, that will be 0% in that case. So make it 100%. If one of them is 99%, the other one is 1%, because both of them has to complete 100%. Okay, my dear listeners, viewers, healthcare providers, once again, please don't forget, these are all the exam questions from ARDMS, similar questions. They are practice questions. If you understand this concept in these questions and you can have better score on these questions, I'm 100% sure you will make your exam to very high score, passing score. Take care, and please don't forget to share the channel to with the others, and tell them to subscribe it as well for the upcoming notifications. We will have for vascular also the same thing. We will have it for echocardiography, the same questions. We will have different questions from the echocardiography, our research exam. We will have it for general abdomen, small parts, and we will also have it for the OBGYN and MSK also. But this is only for physics right now. I'm working on the others too. See you and take care.